Good morning, good afternoon, or good evening. This is going to be a full paper work through of the 2019 paper 1HR for iGCSE Edexcel. As always with these, I haven't looked at the paper beforehand, and this is intended to be as much as a first view to try and give you the best impression of how to tackle one of these papers successfully. First thing to always notice is make sure that you've got all the equipment that you need nearby. Have you got your calculator? Have you got your pen, pencil, ruler, etc. ready to go? We're going to jump straight in and we'll go straight to the first question. We have a cylinder. Of course, on the formula page we do have some of the important pieces of information about a cylinder, including the volume and curved surface area. Our cylinder has a height and a radius. It is empty. We're pouring 1.5 litres of water into the cylinder, and we want to work out the depth of the water. Now, the first thing to remember is that 1 litre is 1000 centimetre cubed. A useful fact is to turn this into the required units. So we actually have a volume here of 1500 centimetres cubed, and from the formula page that's equal to pi r squared, r being 8.2, times by the depth of the water. Now notice I haven't put 10 there. We have not filled out the container, so we don't actually know that depth, and that is what we're trying to work out. So a bit of a rearrangement and then a calculator. 1500 divided by pi r squared. Let's type that carefully into my calculator. Best bet is to hit the fraction button first and then use the arrow keys to help you move around to put things all in the right places. And that comes out as 7.1009, etc. Now, I always like the habit of writing out more decimal places than is needed for your first and then round it afterwards. And our answer, 7.1 centimetres. Question 2. We have now our polygon question. We have interior angles. A regular polygon is 162. We want to work out the number of sides. So there are two formulas that will be useful. So either we could use the interior angle is m minus 2 times 180 over n. But you'll notice that formula is quite ugly. So instead, let's use the exterior angle formula, which is 360 divided by n, which is much simpler of a formula. And if the interior angle is 162, 180 minus that gives you the exterior. So n is 360 over 18. Now I think that's 20, but checking your calculator anyway, indeed gives you 20 sides. First two questions have just been using formulas. Set theory now. We have our universal set being the numbers from 11 through to 20. A is even, B is multiples of 3. Now, a lot of really great things I see people do with these is to actually write those out in a lot more detail. So 12, 14, 16, 18, 20 is A. That's going to make my life much easier later on. And multiples of 3, 12, 15, 18. So the members of A intersect B. That's the things which are in A and in B at the same time. So it's your even multiples of 3 is 12 and 18. A union B. I'm going to write out everything that's in those two sets. So it's every even number, every multiple of 3, which is actually just going to look like the even numbers, but include 15. That's the only one that's not there. And then A dash, the dash is the not. So this time we're not looking for the evens, this is now asking for the odds. Again, I'm restricted from 11 to 20 and not allowed to put anything else in there. Key point about those, you're not allowed to have repeats. You don't need them in order, but it is quite nice to have them in order. Question 4, a nice solve question. Let's undo the layers. I'm going to move the smallest amount of x to the other side, so now I have x only on one side. And then start to undo the layers. Subtract the 17 to get rid of it. And finally divide through by the 4. And that should be negative 7.5 or 15 over 2 if you prefer to leave it improper. To finish off that question, let's just put the answer on the answer line. Carrying on from there. Right, 720 is a product of the prime factors. Lots of different techniques for this. I like the prime factor tree. You might prefer, there's a method called the chimney. And how you split up is, again, independent to everyone. It depends what you spot as the factors. I'm trying to do it fairly efficiently with a very wide tree rather than quite a narrow, long tree. But of course, one technique is always just to keep taking out factors of 2 until there are no more factors of 2. You'll always get the same answer, and notice I've grouped them by their powers. 2 to the 4, 3 squared times 5. And if you do remember, you do have that trick on your calculator using the Shift Fact button on your calculator. We can see that we've got our answer right immediately. Find the smallest whole number that can be multiplied to give a square number. All something to notice about square numbers is all of the powers in the prime factor form have to be even. We'll notice that 2 to the 4, that's even, 3 to the 2, even, but the 5 doesn't have a pair, so to make this a square number, we just need to multiply by 5 to give that an even power, so that the prime factorization only has even powers. And just to really make that explicit why that's a square number, we can factor out that squared. And if you wanted to, you could work out all those numbers and work out which square number this actually is, but not necessary. Question 6, some percentages. We're increasing all the prices in our restaurant by 8%. Before I even read on, I've got a strong feeling that I'm going to need the multiplier here. An increase by 8% is a multiplier of 1.08. Before the increase, the price was $4.25, and we want to find it out afterwards. We're going forwards in time, so the multiplier multiplies. 4.25 times 1.08, which is, this is where I failed to do the symbol, 459. After the increase, the price of lasagna is $9.45. Well, now I'm going back in time. Well, the opposite of multiplying by the multiplier is dividing by the multiplier. Don't fall into the trap of the opposite of an increase is a decrease, because that's very rarely. Actually, I don't think that's ever exactly true. Dividing, however, is the best way to go back in time, and we get 875. Let's use the right currency. Notice that there were a decent number of marks. It's 3 marks each. If I just wrote down 459, I would get all 3 marks, but I should be showing a lot more working. The number of marks should justify the amount of working space, almost always. We have the area of a triangle. Now they've given us the hint here straight away. They've given us the fact that we can split this triangle into 2 halves, both of which are right angled triangles. So actually I need to try and work out this base here. Now, I'm putting that x only on one of these right angled triangles, then I can use half base times height. Well, right angle triangle missing one side is Pythagoras. So let's set up our Pythagoras. Again, I'm showing working as as sensibly as is possible. I'm not going to be excessive, but I am going to show enough. Doing that calculation, subtracting off the 6 squared from the 7.5 squared gives me 20.25. The square root of that is 4.5. So I have that b to the centre is 4.5, so the whole of BC I can now label as 9 centimetres, and therefore area is half the base times the height. Half 6 times 9 comes out as 27 centimetres squared. Now I will forget to put my answers on the answer line every so often. Of course, that's something that you should do. 10 people in a lift. These 10 people have a mean weight of. 3 people get out with a mean weight of. We want to find the remaining mean weight. Well, the trick with these reverse mean questions is always to find the total weights. So let's find the total of the 10. Well, that's 10 of them with a mean weight of 79.2. The total weight of the 3 that left, well, there are 3 of them with an average of 68. 3 by 68 is 204. Well, then that gives me the total of the 7 left by subtracting. 204 kilos worth of people have left. We're leaving behind in the lift 588 kilos. Well, we wanted the mean of that. We've just worked out the total was 588. There were 7 of them. Dividing that by 7 is 84 kilos. It was a whole number. That probably means we've done a good thing. And also notice that the people who left were the lighter people, so we should expect the average weight to go up. Question 9 is some indices work. Do you remember the laws? Dividing, subtract the powers. Multiplying, add the powers. A power of a power, we multiply the powers. If I said multiply for the one above, I do apologise. But remember, the 5 has to be hit by the cubed as well. So that'll be 125 being 5 cubed. There was a hidden power of 1 on the x, making that now x cubed. And finally, y squared cubed gives you a y to the 6. Question 10. 22 meters per second converted into kilometers per hour. Let's do this in a couple of stages. Because I don't really like decimals, I'm going to go for converting into per hour first. That means I do a lot of my multiplying to start with. So from meters per second to meters per hour, well, there are 60 seconds in a minute and 60 minutes in an hour. An hour is a long time, so I expect to go much further. So just by logic, I should be expecting to multiply by that conversion rate times in by 60 squared. Well, then let's turn into kilometers per hour now. There are 1,000 meters in a kilometer. Kilometers are quite big, so we expect a much smaller answer. So division is the sensible choice, and therefore 79.2. Question 11. 3 years ago, we have a ratio of 2 to 7. Tom is now 15 and Clemmy is x. Find the value of x. Okay, so we have something to do with now and 3 years ago with Tom and Clemmy. So Tom is now 15. So 3 years ago he was 12. But we also know that was a ratio of 2 to 7. 12 is 2 parts, so 1 part equals 6. 6 times 7, that means 3 years ago Clemmy was 42. And to go back to present day, let's add that 3 back on. So Clemmy is now 45. Setting things out nicely is often a really good way to make questions seem a little simpler than they necessarily are. Question 12. Pressure is force over area. No doubt I'm going to need to use that. A box in the shape of a cuboid is put on the table. The whole of one face will be in contact. The force exerted by the box is always 105. The box has those dimensions. Okay, the greatest pressure is and the least pressure is, and we want to work out the difference. So let's try and work out the greatest pressure first. Well, it's always going to be 105, but we're going to have to divide by the smallest possible area. We know a small area means a bigger pressure. The smallest area face that I could create is the 3 times 4. So dividing 105 divided by the 3 times 4 gives a pressure of 8.75. Q is still the same force, but now I want the pressure to be as minimal as possible. So let's divide by the biggest possible area. The biggest possible face I could have is the 5 by 4. So this time I'm dividing by 20, giving the smallest possible pressure of 5.25. So therefore P minus Q is the difference between those two values. 8.75 minus the 5.25 comes out at 3.5 pascals. I didn't put units on the answer line. Oh, they have given you the other version of the units there. 3.5 newtons per meter squared. We're now probably moving just past the staples. Of course, on the iPad version, I don't know where the staples exactly are, but this is where we start looking at those more difficult questions. And straight away, we get quite a nasty shading a Venn diagram question. On the diagrams, shade the set A union B, complement of, and C. So that's saying I have to be inside C and outside the A union B. Now if you remember, the A union B is the whole of this double circle. So I need to be outside of that while also being inside of C. Well, the only section which is outside that double circle and inside the circle B is this orangey reddy shaded section. And for the examiner, I'm also going to rub out that first bit of shading, make it absolutely clear what I intend the solution to be. Let's double check. Is that outside A union B? Yes. Is it inside C? Yes. Now we need to go the other way. Use set notation to describe that shaded region. Well, that is inside F, so I'm surely going to have an AND F, but it's also inside D or E. D or E. And notice it's now exactly the same as our original, but without that complement. And you can kind of see that these two would combine together to give that bottom circle, which is exactly what happens when you have a complement and the normal coming together. Question 14, a tree diagram. Each day Barney goes to college. He either goes by bus or he walks. Probability of going to college by bus is 0.3. Well, that means the walking is 0.7. When he goes to college by bus, the probability is late is 0.2. Not late, 0.8, adding to 1. When he walks, the probability he will be late is 0.1. Not late, 0.9. Now that feels a bit backwards. It feels like if you're catching the bus, you should be on time more often, whereas it's opposite here. And if you know anything about bus systems, that might actually not be as obscure as it seems. Barney's going to college on 200 days of the next year. We want to find an estimate for the number of days he'll be late. So first, let's just work out the probability that he's late. Well, there's two ways to do that. He can catch the bus and be late, or he can walk and be late. So I need to calculate both of those branches. As you go through the tree, you multiply. And for multiple separate branches, you add. So the calculation, I'm writing this out for the examiner and then typing it into my calculator, gives me a probability of 0.13. So now the number of days, the estimated number of days is the number of times we do the thing multiplied by the probability of it, of the good thing happening. That gives me an estimate for 26 times that he's going to be late in 1 year. 4 marks for that question, so really showing all those calculations is heavily advised. Question 15. A straight line has an equation. The straight line is perpendicular and goes through a different point. Well, as soon as I see perpendicular, that means I need to know the gradient and convert the gradient into a different form. So the first thing I'm going to do is rewrite the first equation as y equals mx plus c. So therefore the gradient of that first is 3. Notice how I'm setting out my work. I'm making it very obvious to the examiner what each line means, what it's referencing to. The second line then is perpendicular, so it's a gradient of -1 over the other gradient. So I have my gradient of -1/3, and I have a point it goes to. This is perfect for the y minus y1 equals mx minus x1 form. So y minus -1 equals -1/3 x minus 9. The question's told us how to write it, which means I have to do some rearranging. I'm going to multiply the whole equation by 3. I'll get rid of the third on the right, but there's still a negative sign. So I'm going to expand that negative sign through the bracket. And finally, the question wanted the x and the y on the same side. So let's oblige. Let's add the x to both sides, subtract the 3 from both sides, and I believe that is our answer. A little mental check that I like to do is to sub that in, just to double check I haven't done anything silly with my expanding brackets. 3 times -1 plus 9 does indeed give me 6. I can at least give myself a little pat on the back. Question 16. The particle is moving in a straight line, fixed point is on the line, the displacement of p from O is given by, and after t seconds velocity is. Well, here we need to remember that v is the derivative of s with respect to time, so I'm differentiating this expression. Bring down the power 3 times the 4 that's already there, reduce the power by 1, bring down that 2, reduce the power by 1, and you can either remember that there's a little power of 1 there, which leaves behind a t to the power of 0, or just a linear term becomes the coefficient. Part B, find the time when the acceleration of the particle is 6. So again, we need to remember how acceleration is linked to the other two. Acceleration is the derivative of velocity with respect to time, so I'm differentiating again. Bring down the power, reduce the power by 1, and remember that a number just disappears when you differentiate it. We've been told the acceleration is 6, so that's the equation I'm trying to solve. Add the 12 to both sides, divide by the 24. T is 3/4 or 0.75 seconds. Question 17. We have a histogram this time. No one on the plane is older than 80. Well, that's good because my graph stops at 80. 24 passengers are between 40 and 60. So that's telling me that this section here has an area of 24. Frequency equals area. Work out the total number. Well, on this histogram, I'm missing that vertical scale. So that's something that I would quite like to do. So for that 40 to 60, the frequency density is equal to the frequency divided by the class width, 24 divided by 20. So that bar there has a height of 1.2. Well, to make that fit with my scale, that was the height there. I know it's moved off now. If that's 1.2, then quite conveniently, it looks like these boxes just go up in ones, so that each smaller section is 0.2. Okay, now I just need to work out the total number, which is just the total area. So let's work out the area of every single box. That box has a height of 2 little boxes. 2 little boxes is 0.4 height. 0.4 times the 10 is an area of 4. This one's got a bit more space. I'll write the working for this one. It has a height of 1.8, one little box less than 2, times by the base of 10. So that has an area of 18. The tall one has a height of 6.4, a base of only 5, which gives an area of 32. We have a height of 2 times a base of 15, area of 30. And finally, all the way over here, that's just below the thicker line, so that's a 0.8, a base of 20 is a 16. So now the total number, I just need to add these up, the 4 plus the 18 plus the 32, all the way to the 16. Now as I'm writing, I see a couple which pair up quite nicely, but again, for safety, we type this into our calculator, giving me 124. There are 124 passengers on this plane. We're now going to pick a passenger at random. We want to know the probability is older than 55. Once again, that means we want to find the area of this graph which is above the 55. That line was terrible. Let's try and make it a little bit better. So we already have the 16 people from 60 to 80. I now need to work out this little section here. Well, that had a height of 1.2 and a base of 5. So there are 6 people from 55 to 60. So therefore the probability of being greater than 55 is those 6 people plus the 16 from 60 to 80 over the total. I've got a strong feeling that that'll simplify, but not that much. So I type it into my calculator. Gives me 11 over 62 as my probability. Question 18. A triple bracket. Now it is completely up to you which pair of brackets you expand out first. All of them are going to be on the mark scheme somewhere. I tend to just do it in the order it's written. So I'm going to FOIL out those brackets first and then deal with the x minus 7 afterwards. Our firsts, insides, outsides, and lasts. I'm going to keep that x minus 7 there because I need to deal with it in a moment. I still want to stay mathematically correct. So there's my first expansion done. And now let's expand out with the x minus 7, times in everything in the first bracket by everything in the second bracket. I'm going to start with the 2x squared times each of them, then the 7x times each of them, and finally the 6 times each of them. Once again, there are things which can simplify. If you've done it in this order, the things that simplify are right next to each other. They're quite convenient. And that's going to be negative 43x minus 42. And there's my final answer. Make m the subject of. Well, this is the hardest possible version of this question. We got m stuck inside of a fraction. Be careful not to fall into the traps of trying to multiply just by the 2m. That doesn't work. It's stuck in the denominator. You can't also just subtract m from the numerator. It's stuck in a fraction. We have to deal with that fraction first. Multiplying up by the denominator, we now have a bracket to deal with. Again, you need to make sure that bracket's there, otherwise you're not correct. Expanding that bracket out. Now we get to do the useful thing, which is bringing the m's to the same side. I'm going to subtract m and add p squared y, so that the m's are on the left and everything else without an m is on the right. We're going to factorize. Might feel a bit backwards because we expanded a bracket a couple of steps before, but now we're factorizing a different letter. And finally, we're going to divide to remove that bracket. And our solution nice and clearly as so. Question 19. The 25th term of an arithmetic series is, and the sum of the first 30 is. Find the 16th. This should incite simultaneous equations vibes. We've been given two statements and we've been asked to find something out. Main reason it's simultaneous is we know that arithmetic is all in terms of the first term and the common difference. So if we can write out our equations in terms of those, we'll be home and dry. The 25th term. You need to remember this formula is a plus n minus 1 d. Of course, the 24 is from the 25 minus 1. Is equal to 44.5. Now, I don't like decimals if I can help it, so I'm going to double that equation already. That's going to be 89. Because I know I'm going to have to do some simultaneous equations to this in a moment, I might as well try and make my life easy. The second statement is the sum of the 30 is 765. Well, here we can flick back to the formula page, and this one's given to us. This is n over 2, 2a plus n minus 1 d equals 765. Dividing through by the 15 looks like a good idea. Now I'm hoping the 765 is divisible by 15. Should have checked it before typing into writing the line down, but indeed it does. And now I have two equations which I'm going to call 1 and 2. And notice, because of the choices I've made, the two a's match up perfectly. So I've already kind of preemptively done the simplification of your equations to make it work. They're the same number with the same sign, so subtracting works. I've chosen to do 1 subtract 2 just to make the signs stay positive, which cancels the a's, leaves behind 19d, and 89 subtract 51 gives me 38. Dividing through by 19, again a good pat on the back, that's a positive integer. Probably means I've done some good work here. I still need to find a, so I'm going to go back to equation 1. 2a plus 2 lots of 48 equals, so 2a is coming out negative, which doesn't necessarily mean we're wrong. Comes out as negative 3.5. That feels a bit awkward, so my instant instinct is to go and check in equation 2. So I'm going to do 2 lots of the negative 3.5 I've just found, plus 29 times 2, and my calculator does tell me that's 51. So I can have that tap on the back now. It didn't feel right, but it worked. So that's my A and my D. The question itself wanted the 16th term, which is a plus n minus 1 d. Negative 3.5 plus 15 times 2, which gives me 26.5 as my actual final answer. 5 marks available there for spotting the simultaneous, doing it carefully, and completing the question. Question 20. Now this is a threatening looking question. This is a standard form-esque question, but with indices thrown in. We are trying to work out a to the power of 3 over 2. Well, let's just write out what we know a is to the power of 3 over 2. Well, if we're raising something to a power, each section gets raised to that power. The 25 is hit by the power of 3 over 2, and the 10 to the 14n is hit with the 3 over 2. For the 25, you can just type it into your calculator, or recall that that meant the square root cubed. Square root is 5 cubed, gets us to 125. The 10 to the power section, well, a power of a power, we just multiply the powers. This is going to be 10 to the power of 14n times by 3 over 2. 14 times 3 over 2 was 21, so that's 21n. We've simplified a to the 3 over 2, but it has to be in standard form. Well, to put this in standard form, it has to be between 1 and 10. 1.25 is our only choice. But we can't change the size of the number. I made this side 10 times, 100 times smaller, so the other side needs to get 100 times bigger. To do that, we add 2 to the power. 1.25 times 10 to the 21n plus 2. Really horrible question. It's also telling us we're very close to the end of the paper. It's getting more difficult. Question 21. This is pretty much an A-level question. This is our graph transformations, an easily a grade 9 topic. We have our function. It has one maximum point at 4, 3. Write down the coordinates of the maximum point with these equations. Well, we need to work out what these transformations are. A subtraction or an addition is a translation. Inside the bracket, it does the opposite. So this looks like minus 5, but it actually means we're going 5 to the right. Well, if my point was at 4, 3, 5 to the right is at 9, 3. The 3f of x, well, a multiply links with a stretch. This is outside the bracket, so it's vertically, and it has the normal orientation is how I often call it. So this is a stretch, vertically scale factor 3. Does not affect the x coordinate, but is going to multiply the y coordinate by 3. We now have a graph of a sine curve. A couple of different things, well, 2 different things have happened to this sine curve. We've got the a and the b, both of which are stretches. The A is outside, so that's your vertical stretch. The B is on the inside, is going to be a horizontal squish, being backwards. Well, normally the sine curve, if I try and sketch this incredibly poorly, normally the sine curve does something like that. And I apologize for how shaky that is on the iPad. Normally it has a height of 1 down to negative 1. This is from 2 to negative 2. So that tells me that we have doubled this curve. We stretched it vertically by 2. You can also see that in this region, I've got not 1 or 2, but I've got 3 copies of that pattern. So that means that I've squished it inwards by a scale factor of 3, or a scale factor of a third stretch, which means, because it's opposite, b has to be 3. We squished it inwards by a factor of 3. Challenging question, that one. Question 22. No fluff to this one at all, it just tells you to do the thing. Solve the simultaneous equations. Quadratic and linear means we have to use substitution. So straight away I'm going to substitute the y into the first equation. 3 lots of the 2x plus 1 squared. Expanding brackets, I'm going to do this slowly and carefully, making sure you remember that is a double bracket. So you should write it out twice and FOIL it in full. Expanding out with the 3 now. Do get into the habit of using all the brackets which are necessary. As soon as you get lazy with your brackets, you'll start getting lazy with your algebra, and you'll lose marks because of it. I've noticed a common factor of 2, so I'm going to divide through by 2 as well. Now this you can try and factorize, you can try and quadratic formula. This factorization, although it looks like a horrible thing, isn't that bad. The only way to make 7x squared is by 7x and x. The only way to make a negative 1 is with plus or minus 1. And now just to make sure the signs match up, I need a positive 7 and a negative 1. Getting the positive 7 from those, a subtract 1 from those to make that plus 6 in the middle. So therefore x equals a 7th from the first bracket, or negative 1 from the second. Using y equals 2x plus 1, 2 lots of a 7th plus 1 is 9 sevenths. 2 lots of negative 1 plus 1 is still negative 1. And it's a good habit with simultaneous equations to sub into the other equation to check if they're right. We use that one to find these two values. So let's type into our calculator with that second one. If I do 2 lots of a 7th squared plus 3 lots of 9 sevenths squared, hit equals, my calculator does say 5. So that first pair is a correct solution. And the second pair, well, when you square negative 1, you just get 1. That turns out to be 2 plus 3 equals 5. For the sake of the examiner, let's make our solutions incredibly clear. We have the 7th 9 sevenths and the negative 1 as my two solutions. Question 23. A circle theorems question with algebra, a little bit of algebra in already, just because we want to find that value. B, C, D, F are on the circle. Picture shows it. A, B, C, A, D, A, F, D, B, F, E, and C, D, E are all straight lines. Well, all of that is given in the picture, so I don't really need to read any of that again. I want to try and find this value, x. And this is where we need to be a little bit clever. So some things I notice straight away is we have a cyclic quadrilateral. So this angle there at B is equal to 180 minus the angle at D. That might be helpful. We don't have any tangents, which means we can't use a lot of our right angles and alternate segment theorem style questions. So this one has stumped me, at least briefly. So we have, what else could we do then if we haven't got a clear approach? Sometimes just finding any angle is the useful idea. So I can do some things. I've got 180 minus x there. I've got 180 minus x over there. That's at least a couple of angles. I can say that that angle there is x. Oh, so this is incredibly nasty. There might be alternatives, but I can now work out this angle at F in terms of some stuff. So BFA is 180 minus the other two angles in that triangle. Being careful with my algebra. The 180s cancel. So I believe that angle there at F, what did I say? It was x minus 54. And I can do a similar thing on this side. DFE is 180 minus the other two angles, which is going to be 148 minus x. So that angle there is 148 minus x, but that makes an x shape. That's vertically opposite angles. So therefore, they are the same. X minus 54 is equal to 148 minus x. A bit of a simplification. 2x equals 200. X equals 100. Quite a nice round answer after all of that. Now that solution does worry me just a little bit, because it doesn't appear that I've used the fact that these are on a circle. I've managed to avoid the fact that even the point C exists at all, other than the fact using ABC as a straight line and CDE as a straight line. I'll be quite intrigued if there's an alternate solution to that, which uses some actual circle theorems rather than just, oh, there's the circle theorem I used, sorry, it was the cyclic quadrilateral right at the start. It's the fact that these two are 180 minus each other, that's where the circle came in. So I'm a little happier now. But of course, if there are alternate solutions which use the circleness more explicitly, I'll be really intrigued to hear. We must be getting close to the end. We haven't seen the end of questions yet at the bottom yet, so I'm presuming we've got one more after this. This is our vectors question. OA is A, OC is C, A to B is also 2C. So I'll label that onto my picture as well. P is on the point in the ratio of 3 to 1. Q is on the point such that OQP is a straight line. Okay? Use a vector method to find that stuff. Now I believe this is one of the most challenging versions of this question, where it's almost simultaneous in some sense. So we need to try and use the fact that OQP is a straight line. So my technique is going to be to find OQ, I'm going to find OP, and because they're both parts of the same line, there'll be a scalar multiple of one another. The difficulty, of course, being is we don't know where Q is. Let's give that a go. Anyway, let's start with OP, because I could work out OP fairly easily. OP is OA plus, well, A to P is 3/4 because of the ratio of A to B. So that's going to be A for OA plus 3/4 of 2C. I was expecting it to be a B, and therefore OP is A plus 3 over 2C. Okay. Well, now OQ is some multiple of that. So because it's a straight line, so OQP, a line, means that OQ is, I'm going to call it I'm going to resist doing the further maths lettering. I'm going to call it x lots of OQ. And I've just expanded the bracket out there as well. Another way to get OQ is to use the fact it's on AC. So OQ is also OC plus some amount of C to A. Well, OC is just C. C to A is A minus C. Remembering the fact that if you go from one letter to the other, it's the second letter minus the first letter. So that is YA plus, and I'm going to factor out a thing 1 minus YC. So now I have two ways to write what OQ is. So these two ways have to be the same. By looking at the A's, the X from the one up here has to match the X from the one down here. So X is just equal to Y. Looking at the C's, the 3 over 2x has to equal 1 minus y. We know that's now 1 minus x, because x equals y. Adding x to both sides and solving is telling me that x and y are both 2/5. So what has that said? That has said, by looking back to this section here, that CQ is 2/5 of CA. Well, we wanted the ratio AQ to QC. Well, the CQ part is 2. There are 5 parts in total, so it's 3 to 2. Incredibly challenging question there. Hint for those kind is exactly as we did. Work out 2 ways to write down the same thing. In this case, we wrote 2 versions of OQ and put them equal to each other. And we are now to the final question. A boat sails from X to Y, then to Z. We have some bearings and we have some distances, and we want to work out the final bearing. 3 points, that feels like a triangle. This feels like a sine or cosine rule question. Problem is, we're going to have to try and draw this quite carefully. This is one where you might want to draw and redraw the picture to try and make it look as accurate as possible. Y is on a bearing of 280 from X. 280 is roughly in that direction. And I'll label on an angle in a sec. And Z is on a bearing of 210 from Y. 210 is roughly in that direction. And I'm looking at the distances as well. Y to X is 3.5. Y to Z is a bit further, is 6. So there's my Z. Let's connect it up. Okay. And again, I would suggest redrawing this a couple of times to make it look reasonable. Now I've drawn that angle there, that north line. I don't want that north line. I've also been told that the angle there, which was the bearing of Z from Y, is 210, and the bearing from X all the way round to Y is 280. Now comes the difficult bit. Now we need to try and move these angles to allow us to use sine or cosine rule. Now I want the bearing of Z from X. So my final answer I want is that angle there. So a sensible target would be to work out this angle here, which looks quite good because I have an opposite pair for sine rule. But this means I need another angle in my question. Let's start moving angles around and seeing what happens. That angle there in blue is going to be an 80 degrees. And then I have the classic C shape that we often have with these bearing questions. So those two angles add up to 180, i.e. this angle here is 100. Well, that works out that the angle on the inside of y, the whole thing was 220. I've already worked out the 100, so I'm left with 120. Well, the awkward thing is now is I don't have that pair. I would like to use sine rule with these two, or with those two, neither of which is complete. So it looks like this is even worse, and we have to use both sine and cosine rule to get to my answer. A bit of a think, and I believe that is unfortunately the case. So let's use cosine rule first, as the pen decides to turn itself off. Let's use the cosine rule first. So the cosine rule is going to try and find the side xz. Cosine rule says that side squared is equal to the square plus the square minus 2 lots of the BC cos A. Again, that formula is on your front page and just applied carefully. And we're going to type all of that into our calculator. And we get 69.25. So xz is the square root of that. It's not a nice number, so I'm going to keep that in my calculator and use it as the answer, is 8.32. A quick little think of the real situation. If I've gone 3.5 and then 6 at that angle of 120 in between, I'm expecting a longer side, and indeed I do. So now let's try and use the sine rule. I wanted to use the sine rule with this pair with the pink. So sine of that pink angle, and let's actually give it its name. Let's call it theta, so I don't need to write out loads of letters. Sine theta over 6 is equal to, and the other pair that I now have is the 120, and this thing I've just worked out. So sine theta is 6 sine 120 over, and when I type this into my calculator, I am going to use the answer function for the denominator, so I can keep the accuracy as high as possible. And therefore theta equals sine inverse of that answer, 38.6, etc. So that was my pink angle. Now we didn't want the pink angle, we wanted the red angle, which would be the bearing. So looking back at my picture, 280 was the entire way round. I've worked out that inside bit was the 38, so that red bearing of Z from X is going to be the 280 minus the thing we've just worked out. 280 minus answer gives 241.36. And of course, a bearing we write as 3 figures, rounded to the nearest degree, 241. That is the end of the paper. Of course, at this point, you would go back, check through all your answers to look for any silly errors. I'm going to stop there. If you do have questions or queries, please do ask. Otherwise, enjoy the rest of your day.